Hey, Precalc students. So I'm going to continue on some of the trig that you were working on last week. Today I'm going to talk about circular motion. And when we're talking about circular motion, there are two different types of circular motion. There is angular speed, and that is, so here I got a little tractor here. Angular speed is basically talks about how fast the wheels are turning, right? And then the other type of speed is linear speed, and that's how fast you're moving down the road. So when you're talking about your car going, a lot of times you have on your car you have a tachometer, which tells your revolutions per minute. That talks about how fast the engine's turning, and then your speedometer tells how fast you're actually moving down the street. So those two different things. So first of all, we're going to look at angular speed first, then linear speed because of the way they work together. And so I have a little document camera here. Here's for angular speed, we use W for that letter. And so we say the angular speed is equal to the central angle divided by time. So the central angle, that's always when it's in radians. So in the last lessons you did on trig, you were doing, you converted from radians to degrees. You also found arc length. And so we're going to be using that as with what we're doing here. So to find angular speed, you just find out your central angle, you find out what that is in radians, and then divide that by time, and that gives you your angular speed. All right, it has a little bit more to go there with that. Okay, linear speed, on the other hand, all right, using my good old whiteboard, brought one home from school. All right, linear speed, we use the letter V for that, and that's equal to arc length, which we use the letter S, divided by time. Okay, and arc length is just as you found out in doing the other ones for the trig stuff, is that's equal to theta in radians times the radius of the wheel or tire or whatever the object is we're doing, right? And so an easier way, another way to think of them is you'll want to write all these down, is that if we know the revolutions, so how fast it's turning in revolutions, whatever the object is, and we multiply that by 2 pi, then we get our angular velocity. And then when we multiply that by the radius, then we get the linear velocity. You can't say it very well, but it's linear. So revolutions, how fast the wheel's turning, times 2 pi gives you your angular velocity, and your angular velocity times the radius gives you your linear velocity. Now, if you want to go the other way, you want to go from, they tell you the linear velocity, and they want you to know how many revolutions per minute it's turning. Then we have to divide by r to get angular velocity, divide by the radius, and then divide by 2 pi to get revolutions. The biggest part of this is going to be the fact that you have to be able to do conversions, because you're going to be converting from feet to miles, from inches to miles, from seconds to hours. And so the biggest issue we'll be dealing with is going to be working with that. All right, so I'm going to clean this board off here and do a couple of examples for you then. All right, so you can see here that, that for questions 1 and 2 here, it says a bicycle tire with a radius of 14 inches rotates at a rate of 125 revolutions per minute. Now we're going to go backwards. We're going to do number 2 and then do number 1. So we're going to find the angular velocity and then the linear velocity. So, all right, back to our whiteboard here. Okay, so it says, first of all, radius is 14 inches. So we'll do radius equals 14. And we have 125 revolutions per minute. So 125 revolutions per minute. So RPMs, all right, which is what you see on your car. So we want to find the angular velocity, so that's W, and that equals to the central angle time divided by time. Well, or what we just said was that we can take that, and all we have to do is take the revolutions to find the angular velocity, take revolutions, which is 125 revolutions per minute. All right, so I was right as a fraction, and we're just going to multiply that by 2 pi. All All right, so that's going to be equal to 250 pi, and we'll use pi, leave pi in there, and that is in radians per minute. All right, so kind of ran out of room there, but radians per minute. So 125 times 2 pi, 250 pi radians per minute is our angular velocity. That's the answer to that question number 2. Question number 1 says to find the linear velocity, but it says to find the linear velocity in inches per minute. All right, so this is actually pretty easy then as far as that goes. So we have 250 pi radians per minute. And to get the linear velocity, then we're just going to multiply that by the radius, which is 14 inches. So we have 250 pi times 14 inches per minute. All right, so I'll take out my calculator. Take 250 times 14, so 3,500 pi inches per minute. And if we want to write that as a decimal then, which they will quite often, so that'll be 10,995.6 inches per minute. All right, so our angular velocity is just multiply the revolutions times 2 pi. Angular velocity then, or linear velocity then, we just multiply that by the radius, and then we just have to worry about doing any conversions. All right, so let's look at another one. All right, question 3 and 4. It says a CD with a diameter of 120 millimeters rotates at a rate of 45 revolutions per minute. All right. So first thing we want to do is identify the things that we know. So they tell us that it has 120 millimeters diameter. We don't care about diameter. We want to know radius. So this has a radius of 60 millimeters. All right, and it's moving at 45 revolutions per minute. All right. All right. We want to find the angular velocity. So we'll take, so that's W again. So we're going to multiply 45 revolutions per minute and multiply that by 2 pi. So we get the angular velocity is 90 pi revolutions or radians now per minute. As soon as we multiply by 2 pi, we're changing it from revolutions to radians. All right. So now to find the linear velocity, V, we're going to take that answer and then multiply it by the radius, which is 60 millimeters. So radians per minute, and multiply that by 60 millimeters. So that gives us 5,400 pi millimeters per minute is our linear velocity. Okay, so that's how fast it's moving down the road. And we'll just change that to a decimal. And we get 16,964.6 millimeters per minute. All right, how fast it's moving. So like I said, the biggest thing for these problems is going to be the fact that they are going to be unit conversions. All right, so we're going to look at one now. The last one I'm going to do is going to be about basically doing the conversions for it. And so I'm actually just going to put my sheet up here and explain it to you with what I've already done. All right, so here's the problem, is the last one down here, number 5. All right, so it says a 16-inch diameter tire on a car's is making 500 revolutions per minute. Find the linear speed of the tire in miles per hour. So here they tell us that the diameter is 16 inches, so that tells us the radius is 8, and it's making 500 revolutions per minute. Okay, so first of all, we're going to find the angular velocity before we find the linear velocity. So we're going to multiply that 500 revolutions per minute times 2 pi. All right, and that's going to give us the angular velocity. And then we're going to multiply that by the radius, which is 8 inches. So when we do that, we get 800 pi inches per minute. But the point is they want to know it in miles per hour. So we got to do the conversions. So I've got my 8,000 pi inches per minute, and I need to convert that to miles per hour. So I'm going to go to hours first. So when we know there's 60 minutes in an hour, so you're going to multiply by 60 minutes over 1 hour. Since I'm trying to get rid of minutes from the denominator, that means I got to have minutes in the numerator. Right? So now I know that minutes can now cancel. Right? So they're gone. All right, I'm just left with hours in the denominator. Now I want to change inches to miles. So we know that there are 12 inches in 1 foot. So since the inches are in the numerator here, I want them in the denominator here so that they will cancel out. All right, and then I need to go to miles, and there's 5,280 feet in a mile. So now feet will cancel. And then I can just simplify this. So I'll multiply 8,000 pi times 60 for my numerator, and then divide that by 12 times 5,280 for the denominator, 23.8 miles per hour. So that is the basis of doing circular motion. And like I said, the biggest thing for you is going to be the conversion from getting it from wherever they start to their finish, which is usually miles per hour. All right, I'm going to put some problems on Google form for you to do, and it'll have the answers there to you'll be able to check your answers for them. Actually, what I'm going to do is I'm going to put the handout on on Schoology, and the answers will be a separate handout, so you can check them when you're done. And if you have any questions, just send me a message.